Hello students, welcome to ePathshala. Now we are going to learn about quantitative tests of fibers. The fabrics are made up of different type of fibers like cotton, silk, polyester, nylon, like several other fibers. So fabric is a very important property. The fiber is going to plays a very important property. So we have to find the quantitative analysis of the fiber. First of all, what is meant by quantitative analysis of fiber? So if you are given a sample of fabric, you have to analyze the fabric which is made up of fiber, which fiber it is going to be made, so that we can reproduce the fiber as per the specification. For this we have got several number of tests. One is called non-technical test and technical test. In case of non-technical test, it may be of burning test and feeling test. In case of technical test, this may be a chemical test, burning test, and also solvent test. These are the very important parameters we are going to test, so that we can identify the fiber based on their approaches towards the properties of test. For example, if the cotton fiber is going to be dissolved in sulfuric acid, we can confirm the material is made up of cotton. In case of silk, if the material is going to dissolve in sodium hydroxide, we can confirm that the material is made up of sodium hydroxide. For example, if the cotton fiber is going to be burned, it will have a paper burning smell. So from this we can identify that we can have which fiber it is made up of. So it is very important. We have to know the fiber, the behavior of the fiber in melting, burning, chemical solvent, etc. From this module we can able to find which fiber which will be dissolved in the chemicals. So this module is very helpful for the student to know the quantitative analysis of the fiber. After going this lesson, the students can identify the fibers using wide range of techniques. Observe the longitudinal and cross-sectional microscopic view of different fibers with their respective unique features. Understand the different burning characteristics of fibers. Distinguish between the fiber types using the criterion of solubility in a chemical. Distinguish fiber on basis of density and melting temperature. Then what are the range of tests to be done? One is called microscopic examination, which gives a longitudinal and cross-sectional view of the fiber. Second one is burning test in a flame. The third one is solubility test in chemical reagent. And fourth one is element identification. Fifth one is density measurement and determination of melting point and peeling test. What are the type of textile fiber test will be? We can classify into two categories. One is called non-technical test, another one is called technical test. So non-technical test will comprise of peeling test and burning test. In case of technical test, microscopic test and chemical test. So test for the identification will be made up of handle or field test and also visual examination. Another one is burning test, twist on drying, flotation test, microscopic analysis and chemical analysis. Now we can go for what are the requirements for test. So for the requirement of test, how to test will be done will be, you have to prepare the test specimen, and we require a pair called microscopic if you are going for microscopic examination, and we need some chemicals or reagents for the chemical test if you are going for solubility test. And in case of non-technical test like feeling test, the feeling test requires perception if it is to be of any value. So it requires skilled operator and also experienced operator. Skilled perception is occurred only after handling many different fabrics over a period of time. So limitation of this test become apparent when examining and comparing fabric of different fiber content. On the whole, feeling test does not give any quite confident test result, so that it is not a confident test. So next time we are going for burning test. To recognize the composition of fabric by burning test, the sample of fiber or yarn of fabric should be moved slowly towards the small flame. The reaction of heat carefully observed. One end of the sample should be put directly into the flame to determine its burning rate and characteristics. The burning order should be noted and the characteristics of ash such as amount of ash, form of ash, hardness of the ash and color of the ash should be examined in the case of burning test. In the case of technical test, there are certain technical tests performed for identifying various fibers. These tests require high technology laboratory equipment and are much more reliable than the non-technical tests. The technical tests require a high skilled personnel and technical know-how of handling chemicals and their accurate analysis. These tests are very valuable for those fabrics that are blend of different yarns and also have certain special properties including flame retardancy, water absorbency, etc. So types of technical tests will be microscopic test and chemical test. There are two types of tests which can be microscope, under microscope, and we use chemical for identification of the fiber. So under microscopic test is a technical test that involves identifying the fabric with help of microscope with the magnification of minimum 100 power. The test can easily distinguish between fibers. The test identifies the natural fibers more easily as compared to man-made fiber. Synthetic fibers are very similar in appearance and the increase in the number of varieties makes it little bit tough to distinguish fiber even under microscope. For in case of technical test, if it is going to be for natural fiber, we can identify the fiber by the longitudinal cross-sectional view. We can find the fiber easily because in case of cotton, the cross-section will be of kidney shape so that we can identify easily. But in the case of synthetic fiber, microscopic test doesn't reveal much result because all synthetic fiber have similar cross section, so we are not able to identify the fiber easily. So we are going for chemical test. Chemical tests are another technical means of identifying fibers, but chemical tests are not intended for the general consumers. Different types of chemical tests are undertaken to establish the identity of the fibers used. These tests give accurate and precise analysis. The tests are conducted in the research laboratory only. Fiber identification by solvent test. This is another method. For example, if the blend is composed of polyester and cotton, the one component is going to dissolve in one chemical and the other one is identified by remaining residue. For example, solubility of fiber in a particular chemical reagent is a means of identification in case of solvent test. The fiber can be placed in a chemical at a particular temperature and the solubility will confirm the type of fiber. For example, in cotton is going to be soluble 75% sulfuric acid. In the case of woolen silk, 5% sodium hydrochloride or 5% sodium hydroxide at boil will make them dissolve. So we can identify the fiber. If it is going to dissolve in 5% sodium hydrochloride, the material will be wool. If it is going to be dissolved in 5% sodium hydroxide at boil, the material will be silk. We can identify this as a silk material. In case of viscose, it can be dissolved in 60% sulfuric acid. So in case of acetate, if the fiber is acetate, it can be dissolved in glacial acetic acid. In case of triacetate material, it can be dissolved in acetone. In case of nylon material, it can be dissolved in hydrochloric acid or in formic acid. In case of polyester, it can be dissolved in metoxazole or chloroplenol. Acrylic material can be dissolved in dimethyl formaldehyde. So from this, we can identify that the material, if it is a cotton or nylon or polyester, by using different type of soluble solvent. So methods available for characterization fiber, structural and physical chemical properties are: one, we can use optical electron microscopy and elemental end group analysis, or infrared spectrography or ultraviolet visible spectrography. Both are different methods to identify the material. For example, in case of optical electron microscopy, it gives the fiber longitudinal and as a cross-sectional view. In case of elemental end group analysis, it gives the fiber end group which component will have. For example, COOH or OH group. Infrared microscopy will give valuable to the determination of functional group within a fiber. Which are the functional group present in the fiber. Ultraviolet visible spectrography will give an idea of electronic transition occurring during the heating. This will give the unsaturated groups which will be in the excited module. There are some other methods available Nuclear magnetic resonance spectrography, which will have NMR, it will give the high intensity magnetic field so that the orientation of the molecule inside the fiber can be determined. And another technique is called X-ray diffraction. It will give the crystalline amorphous region in the fiber. Thermal analysis is also done for physical chemical changes in the fiber during the fiber analysis test. Then also molecular weight determination will give the size and weight of the fiber molecules. Then specific gravity test is also measured to density of the fiber, which can be give the density of the fiber. Then microscopic test reveals the microscopic features of the fiber. When observed along the length and surface feature can be revealed. Cotton fiber, the longitudinal cross section will be flat, irregular, convoluted ribbons under microscope. In the case of cross section of the cotton fiber, it is a peanut or bean shaped with lumen running along through the length. In case of wool, if it is observed in the microscope, it have rough surface with scales protruding out. In the case of cross section of wool under microscope, it is nearly round. Medulla present in the coarse fiber is concentric and irregular in size. In the case of silk fiber, it is very smooth and distinct lengthwise in the longitudinal cross section, and in the cross section idea, mostly triangular cross section. In the case of viscose rayon, it is a striated smooth cross section in the longitudinal view, and in the case of irregular serrated cross section in the cross sectional view. In the case of nylon, polyester and polypropylene, it is smooth rod-like structure in the longitudinal section, and in the cross section it is regular and round. In the case of acrylic, it is a flat, irregular striations in the longitudinal view. In the case of cross-sectional view, the acrylic will look like a irregular, dog bone shape like structure. So we can identify the fiber by using microscopic view also. In the case of burning test, the fiber being chemically different, so different burning characteristics can be used to identify them. The burning test is a relatively simple test, as all needed is a flame, that's all. So we can make observation when approaching the flame, on the burning behavior inside the flame, during the removal of the flame, relating to smell emitted, and the residue of ash. For example, for a cellular fiber, approaching the flame, it do not shrink. In the flame, burn readily without melting. Behavior outside the flame, continue to burn after glow. Smell of cellulose fiber when burning, especially cotton and viscose, will have burning of hair, human hair. Residue will be small amount of light grey ash. In the case of wool and silk, when approached to the flame, it will curl away. When it is in the flame, burn slowly, sputter like anything. Behavior outside the flame will be self-extinguishing. It will extinguish self, no need of extinguish the fiber, and smell will be the same as that of cotton, that is burning like hair. Easily, in the case of residue, the ash will be easily crushable and black bead like the thing. In case of polyester, when approached to the flame, it shrinks away from the flame. In the flame, when it is in the flame, melts and burns slowly, drips. When the behavior outside the flame, burns, drips, may extinguish because of dripping. Smell, sweet smell of ester. Residue will be hard, tough, grey bead. In the case of nylon, the same as that of polyester it will have, but in the residue will be hard, tough, light color. In the case of acrylic, the residue will be irregular, hard, black bead like of polyester. So we can identify the fiber during burning. Then in the case of solubility test, there are 7 steps available. In the case of the fiber is unknown fiber. If you are given an unknown fiber, there are 7 steps. First step, treat the fiber sample with 0.2 to 0.5 sodium hydrochloride solution. If the fiber soluble, they may be wool or silk. To distinguish between the two, whether it is wool or silk, treat the fiber in cold 70% sulfuric acid. If soluble, it can confirm it is silk, otherwise are wool. Alternatively, the test the fiber of sulfur which present in the wool. If the fiber is insoluble in sodium hypochlorite, go to step number 2. In the step number 2, treat the fiber with cold acetic or glacial acetic acid. If the fiber is soluble, the fiber could be cellulose or diacetate or cellulose triacetate. To distinguish between the two, treat the fiber with methylene chloride. If soluble, it is cellulose triacetate. If it is not cellulose diacetate, if the fiber is insoluble, go to step number 3. In step number 3, treat the fiber with cold formic acid. If soluble, the fiber is nylon 6 or nylon 6. To distinguish between the nylon 66 and nylon 66, treat the fiber with boiling dimethyl formaldehyde, usually denoted as DMF. If the fiber is soluble, it is nylon 66, otherwise it is nylon 66. So in case of if the fiber is soluble in dimethyl formamide, the fiber is nylon 6. Alternately, determine the melting points. If you have a doubt, go for melting point. Nylon 6 melts at 218 degrees centigrade. Nylon 66 melts at 265 degrees centigrade. If the fiber is insoluble in DMF, go to step number 4. Still, we are in the case we are not able to find it is not wool, it is not silk, it is not nylon or nylon 66 or nylon 6. We are going for nylon. So next step number 4. Treat the fiber in cold DMF. If it is soluble, it is acrylic fiber. If it is insoluble, go to step number 5. In the case of step number 5, boil the sample in chlorophenol. If soluble, it is polyethylene terephthalate, that is polyester. If the sample is soluble in chlorophenol, it is a polyester fiber. If it is insoluble, again go to step number 6. Treat the fiber with 70% sulfuric acid. If soluble, it could be cotton or viscose rayon. To distinguish between the two, treat them with sodium zincate. If soluble, it is viscose rayon. If insoluble, in step number 6, go to step number 7. Step number 7, put the sample in water. If it floats, could be polypropylene, that is PP, or polyethylene. PP is soluble in boiling carbon tetrachloride. PP is soluble in boiling xenol. So in the 7 tests, we are going to identify whether the fiber is going to be a silk or wool. Go for second test. Going to be for solubility test. For additional test, we can go for, if you have a doubt, nylon 66 and nylon 6 can conform in formic acid 85% or M-cresol solution. If it is a cellulose triacetate, it can be soluble in chloroform or methylene dichloride. If it is wool fiber, it is soluble in 5% sodium hydroxide at room temperature. In case of silk, it can be soluble in 5% sodium hydroxide hot solution. In case of viscose rayon, it dissolves in sodium zincate solution. In case of polyester fiber, it dissolves in orthochlorophenol at room temperature. These are the some of the additional confirmation tests we can make for nylon 66, nylon 6, cellulose triacetate, wool, silk and viscose rayon. So another measurement is called density measurement. The definition of density derived from the relationship in volume into density is equal to mass. That is, the density is the mass per unit volume of a substance and its units in grams per centimeter cube. It can be accurately measured using density gradient column. We can use a equipment called density gradient column to measure the density of the fabric, density of the fiber. The fiber density is being given like this. The cotton will have 1.52 to 1.55 grams of centimeter cube of density. In case of viscose rayon, 1.49 to 1.52 density will be having. If the material has got 1.53 to 1.55 density, the material will be linen. In the case of jute, it will have a density of 1.49 to 1.5 grams per centimeter cube. In the case of silk, the density will vary from 1.25 to 1.34 grams per centimeter cube. In the case of nylon 6 or nylon 66, the density will be 1.14 grams per centimeter cube. In the case of polyethylene, it will be 0.92 to 0.94. In the case of glass fiber, it will be 2.54 to 2.54 grams per centimeter cube. In the case of polyester, it will be 1.38 to 1.4 grams per centimeter cube. By using density gradient column, we can measure the density of the fiber, and by referring this table, we can roughly come into the idea whether the fiber is cotton or viscose rayon or polyester or silk or wool. Then another test will be the melting point, determination of the melting point of the fiber. The melting temperature of the fiber can be accurately determined with the help of differential calorimeter. Cotton will be decomposed around 250 degrees centigrade before softening or melting. If the fiber is wool, it will decompose around 220 degrees centigrade. In the case of silk fiber, it decomposes at around 280 degrees centigrade before it melts. Man-made fiber, in the case of man-made fibers, if it is viscose rayon fiber, it decomposes before softening or melting. In the case of polyester, it decomposes around 265 degrees centigrade. In the case of nylon 6, the melting temperature will be 218 degrees centigrade. In the case of nylon 6,6, it will be around 265 degrees centigrade. In the case of acrylic fiber, it may be the melting point will be 320 degrees centigrade. It may decompose before melting. In the case of polypropylene, the melting temperature will be 165 degrees centigrade. In case of polyethylene, in case of low density polyethylene, the melting temperature will be 115 degrees centigrade. And in the case of polyethylene, high density polyethylene, the melting temperature will be 150 degrees centigrade. So we can identify the blend composition by using longitudinal view or microscopic test, burning test, melting point test, and also solvent test. So one can able to identify the fiber by any one of the method. If it is the unknown fiber, we can go for the 7 step, which can be step by step. We can eliminate the possibility of the fiber which is going to dissolve in the solvent. For that, we can find this by the 7-step method. We can identify the fibers of wool, silk, cotton, viscose, nylon, polyester, polypropylene, polyethylene fiber by using the quantitative analysis method. So after learning this module, the student can identify the fibers of the category, which is a man-made fiber or natural fiber. Depending on the fiber, which test has to be done, and which solvent to be used to identify the fiber, which method is used to identify the fiber to confirm the presence of the fiber in the fabric. We can use how to use the microscopic test, how to use the calorimetric test to test the density of the fiber, and also X-ray diffraction methods to identify the fiber in a definite manner, and also burning test, and also the soluble test. So we can identify the fiber by cross section, longitudinal view, and also burning test. This will help the students to learn about their quantitative analysis, which will help the reproduction of the fabric according to the sample.